The concept is simply to tap into the rotational kinetic energy produced from the transfer case and use it to power an electric motor generator that is affixed to the back of the transfer case.
Welcome to the Heavy Duty Parts Report. My name is Jamie Irvine, and today we're going to be exploring how hybrid power transfer case technology is shaping the future of commercial vehicle systems. To help me with that conversation, I'm excited to introduce you to our guest today. First, I'd like to introduce you to Aaron Rivers, CEO of Emotiv Mobility. Aaron, welcome to the Heavy Duty Parts Report.
Thank you very much. Glad to be here.
And also, we're very happy to have Tim Kelly, lead engineer at Emotiv Mobility, with us as well. Tim, welcome to the show.
Morning, Jamie. Thank you for having me.
So I'd like to start the conversation off, Aaron, with a question for you. What motivated Emotiv to develop a hybrid power transfer case technology, that solution? Like, where did that come from? What was the motivation behind it?
Yeah, that's a very interesting question. So as an individual, maybe some background, I have been in industry for 30 years and fortunately spent in a couple of adjacent markets. So that being commercial vehicle, as well as passenger car, as well as aerospace, as well as rail transportation, right? So the impact of those adjacent markets from a mobility strategy perspective provides a unique lens that perhaps is not something that is normally considered. When you look at hybridized power for commercial vehicle, the use case for hybridized power is typically one that is born by the ability for extra mileage, right? I mean, that's the name of the game in commercial vehicle versus, let's say, passenger car, right? So the idea of having range anxiety in commercial vehicle is something that has been a determining factor on the adoption of electrification in commercial vehicle. And so that idea is one that is all or nothing, right? You're either going to be a combustion engine commercial vehicle or you're going to be an electric commercial vehicle. But the idea of hybridized electric power in commercial vehicle is an area that is not really discussed very often, right? Because again, the use case is typically around range. When we think about the use case for hybridization or electrified hybridization of commercial vehicle, we think about the use case that is one that is of varied application, right? So not just potentially range, but when you think about commercial vehicles have several utility uses that are different than those in passenger car. And so with that idea, that question, that probing, what truly is the impact on electrification on commercial vehicle mobility, born then the thought, well, how do you even drive efficient electrification through a commercial vehicle system? And that then born through that study, landed on the hybridized transfer case.
Okay. So Tim, you're here to provide us with more technical insight. So maybe you could start by walking us through the core concept behind this technology. What makes it different from traditional systems, and why is it such a big deal for OEMs and fleets?
Sure, Jamie. The concept is simply to tap into the rotational kinetic energy produced from the transfer case and use it to power an electric motor generator that is affixed to the back of the transfer case, creating energy for either onboard storage that can be used to either power the vehicle or as an auxiliary power source, adding increased flexibility and opportunities to the vehicle and its equipment. Traditional transfer case systems do not allow adaptability for electrification as the hybrid transfer case does. And offering this ability as a modular add-on solution is important to large fleets, primarily because it drives significant reductions in cost and vastly improves operational flexibility and adaptability, such as cost efficiency, reduced maintenance cost and downtime, operational flexibility and adaptability, mission specificity, scalability, and potentially faster time to market.
Okay, that's a lot. You know, Aaron, and when I think of the conversation around ICE vehicles and battery electric vehicles, electrification in general, especially when it comes to the commercial vehicle market, a lot of people kind of point to the fact that, like, we don't have the ability or the infrastructure to just flip a switch and stop using ICE vehicles and start using battery electric vehicles. Like we just don't have the infrastructure to support that. Many people kind of point out some of the limitations that we've seen with electric vehicle technology up until this point. I personally kind of come from this from a perspective that in the future, it seems to me more reasonable that we should be utilizing every different kind of technology available to us and make it kind of more vocational in picking the best technology for the vocation. That seems to be the most like logical way forward. So when we think about it from a strategic perspective, how does this technology that you're developing actually help bridge some of the gaps that people point to when people are talking about it in more of that zero sum game, only ICE or only battery electric?
That is a phenomenal question. So I can give you our premise, right? So I think you're spot on, and I think the prevailing wind in the market is this totalitarian approach to either or, right? This extremely bilateral discussion. For us, we think that the vocation of commercial vehicle drives the need for different technology use cases, right? So what does that look like? If you think about a use case of a special utility vehicle like a Terex crane, as an example, right? Here are vehicles that are typically, obviously smaller than Class 8, but higher than passenger car. These utility vehicles are often in city and rural locations, which require four-wheel drive, hence a transfer case. And when they get to the field, typically they're running their equipment to do the utilitarian part of the job via battery or some other system. But even if they're using battery or onboard combustion, they're typically in high idle, right? The vehicle's sitting there in high idle. So when we think about then electrification, the idea of a purely electric system cannot work, to your point, right? I'm in a rural county setting. There's no power plug for me to plug into. I have limited range. If I'm a completely electric vehicle, then I'm going to turn around and use the utilitarian aspect of my vehicle, which is going to drain more power. With that being said, if you look at that particular vocation of that vehicle, and now you look at ways for electrification, in that same scenario, you have an ICE vehicle that has four-wheel drive that is typically in high idle out in the field. While it is in high idle, what now is the secondary power use case for that utility vehicle, right? And where is that power coming from? Well, if you think very anecdotally, Tim's an engineer, so he would say this more eloquently than I will. But if you think about that scenario I just gave you, you have the transfer case or you have the system in idle. And the only thing so the system is still generating power, although the power is clutched off, right? So obviously the drive shaft is not spinning. The transfer case is not spinning, as we know. But that power is still there. And that power in this case is throwaway. It's being used for heat. It's being used for other activities. But by and large, this power is just being dissipated, right? It's not being used for transportation or mobility purposes. But if you think about that power and what it could be used for, and you start to think about the drivetrain in general, through that activity of clutching on and off certain aspects of the vehicle, you still have an engine that is running, that is providing power. That power could then be directionally clutched to the transfer case to spin the transfer case itself. And if that transfer case can spin, instead of having the output shaft going to the front axle unit, simply take an output shaft the opposite way and use that throwaway rotational power through a generator and through a converter, then obviously to create power that was not in the system before. Now, this attacks a couple different aspects of the use case for full electrification. One, if you look at battery systems, they're much heavier than combustion systems in one, right? So obviously for commercial vehicle, that is an issue. It takes away from overall range of the commercial vehicle. So this application is one that is far less costly from a weight perspective. It then, when you look at the power that it's generating, it then offers now optionality for the power use case of the utility portion of that vehicle. And so when you look at that as an example, I think it's a very clear example to show that there is a case for hybridization and electrification of commercial vehicle dependent on the vocation of the vehicle. So hopefully that answered the question.
And I think that that's something that people, when we talk about people in general, when I listen to people outside of the industry talk about this subject and versus the people inside of the industry, their perspective on it is so different, right? A lot of people outside of the commercial vehicle industry, their interaction with our industry is maybe like a transport truck passing them on the highway and spraying their vehicle with water, and they're just annoyed. And they're not thinking about the way that the commercial vehicle industry kind of underpins society. It's the backbone of society. On the flip side, I think sometimes when it comes to people within the industry, we have an understanding of that, but we also sometimes get into this mode of thinking where we know what we know and we're maybe a little nervous about the new stuff. And so there's that reluctance to want to adopt change. And I just think that we have to take a step back. We have to look at the opportunities here and we have to maximize where we can to get the benefit we're looking for, which of course is lowering total cost of operation for the fleets and making the trucking and commercial vehicles more efficient, but also to do our part to reduce the impact of this industry. So I really like where you're coming from on that. It's time to hear from our sponsors. We'll be right back. Lowering total cost of operation involves looking at critical components that you put on your commercial vehicles and making sure that you are making the best selection for your application. With all of that in mind, I want to introduce you to the new standard in wheel end protection, the Hubcorp's revolutionary X-Tractor. Now, what I like about this product, it's the only line of hubcaps that comes with a built-in 3-stage magnetic oil filter. And this is a safeguard for your critical wheel end components. In addition to that, it is actually a serviceable component on your vehicle now. And so it has a patent pending hex thread cartridge. And the X-Tractor makes hub oil servicing really simple and easy. And guess what? If you're not servicing that hub oil regularly, you are going to have premature failure of key components. It's just the way it works. So I highly encourage you to get on the wait list today. You can do that by heading over to thehubcorp.com. Check it out, get on the wait list, and you will get the most up-to-date information about when this product is available and also some price discounts that you won't get anywhere else. So go visit thehubcorp.com today. It's not just fleets and owner-operators that need to look at their total cost of operation and find tools that help them with their business. If you're running a repair shop, then you need tools to streamline your operations, and that's why I recommend FullBay. Now, FullBay has features like streamlined scheduling, real-time inventory tracking, technician efficiency insights, and detailed reports on exactly every aspect of the business that you need to be paying attention to make sure that your repair shop is running as efficiently as possible. And what does this mean for you? Well, it means in the end that FullBay is the very tool that's going to help you reduce downtime and make your shop more efficient, keeping the vehicles that you service on the road where they belong. Check out fullbay.com/power to maximize your shop's productivity today. That's fullbay.com/power. Manufacturers and distributors are a key component in the supply chain, and they play a vital role in keeping trucks and trailers rolling. I'd like to introduce you to Equip 360 by Gen Alpha. This platform helps manufacturers and distributors grow their part sales. But more importantly, it helps them make their customers' lives easier. And that's so important. With real-time insights into inventory, pricing, and order tracking, it's going to keep your customers coming back. Plus, it saves time by automating routine tasks and making repeat purchases simple. I encourage you to explore Equip 360 at genalpha.com, genalpha.com. Check it out today. We're back from our break. Make sure you go and check out the links in our show notes to all of our sponsors. Okay, let's get back to this episode. We're back from our break. Before the break, I think we did a great job, gentlemen, of kind of setting the stage of where the opportunities are with this hybrid approach. Tim, I wanted to ask you, from an engineering perspective, where do you foresee some of the biggest engineering challenges in creating a system that supports this dual mode operation and integrates energy storage from the traditional way commercial vehicles were operated when they were only ICE vehicles?
Yes, I would have to say that design packaging of the modular unit within the existing vehicle architecture, that can represent some challenges, having to keep that modular unit somewhat compact. That coupled with the additional electronic controls required for the additional internal clutch actuations to accommodate the various modes of functionality, but both of which I feel the emotive engineering team can and will overcome.
From a non-engineer's perspective, say that again and make it so that someone like myself or someone else listening who's just not an engineer can understand. Make it easier for us to kind of get our head around that, because if you've never had any exposure to this system, it's hard to kind of visualize what you're talking about.
Understood. So you're adding some content to the existing transfer case that's under the vehicle right now. You need to be able to fit, if you will, or what we say in the design community, package that unit within the environment without interference to any of the adjacent, features, componentry on the vehicle. So from what we've seen so far, crawling under a lot of the class 3 through 4 and 5 vehicles, looks like there's ample room to accommodate this technology. And then on the internal side of things, these units are powered with electronic control modules currently. It just requires some additional tweaking, if you will, to those modules for the added clutch actuations, where, for example, if we want to decouple from the ICE-driven powertrain and engage the full electric side, we can do that as well.
Thank you. I really appreciate that. That makes sense. So, Aaron, when you're looking at this from the perspective of it's a new technology, there's an adoption curve there. I'm a big fan of the law of diffusion of innovation. It kind of shows the way people respond to something new, and you've got those innovators and those pioneers, and then you have the early adopters, and then you kind of have, once it starts to gain traction, the largest group of people start to adopt, and then at the end you've got the laggards who maybe never will. It's one thing to get people on the aftermarket side to retrofit these vehicles and to adopt that. It's another thing to get OEMs. So what's been happening there? Like, are there any pilot programs that you've got with OEMs that, and what's their attitude been towards this approach?
So I think that might have been a two-phase question. So I'm going to try to blend it into one, and I'll attack it in bits. Like many commercial vehicle developments, most developments are born on the OEM side through partnerships, right? And specifically deployment partnerships. So we are in conversation with two OEMs that play in both the passenger car and utility commercial vehicle space, without giving out all the detail, as development partners for activities. Both of these OEMs occupy a very, very large market share in that class 3 through 6, 7 space that Tim mentioned. That fit the use case as an example that I provided a little bit earlier before the break. So we do have those conversations in the work, right? And to Tim's commentary, that has to deal a bit with packaging, right? And how you actually fit this new system into the current architecture of a vehicle. So I think that was one nuance of the question. The second nuance of the question revolves around adoption of technology. And when you think about the hybridization of the transfer case and then using that kinetic energy then to drive onboard systems, we are not using technology that is not already tried and true, right? A commercial vehicle, unlike a passenger car, has to do its job, right? You don't buy a commercial vehicle because of aesthetics. I mean, I guess some people do, but you buy them because they provide a service, and that service has to be available on time, every time. And so when you think about the technology that we are looking to deploy, these are all systems from an engineering perspective and from a vehicle perspective that are all tried and true, that are already used in other aspects of commercial vehicle and mobility. And so to Tim's point, he used the non-engineering term tweak. By utilizing those systems that are already tried and true, already available, already well tested in environments, and then putting them together in an overall architecture and package makes the adoption of these types of activities very, very palatable. I remember the first conversation I had with one of the OEM partners that we are in discussion from a development perspective. And it took maybe 4 minutes into the conversation. And the conversation was, we need to meet next week to really understand how we can deploy this in our products from a design perspective, right? So just to give you some color into maybe that other aspect of the question that you asked.
It's one thing to talk about specs, but at the end of the day, people just want to know, does it work, right? And what's the outcomes I can expect? So, Tim, how does this system improve things like efficiency, durability, for those people that operate in tough environments like construction or mining or even the freight market?
The power transfer case, hybrid power transfer case, it can enhance things like efficiency and versatility by producing and reusing the energy that can contribute to lower emissions, supporting eco-friendly transportation, and supporting sustainability goals, such as helping to achieve carbon neutral global operations by 2040 and delivering 50% of shipments with net zero carbon by 2030. It can assist and complement to help with that. Operational cost savings, fuel and maintenance cost reductions are also ways that it can offer increased efficiencies and versatility.
Yeah, and I mean, as an operator of one of those companies, you have this push pull happening right now, right? You've got the demands of today and keeping your business profitable and operating at a high level to do the function that it needs to do. And as we said earlier, those things that the commercial industry is responsible for are so important. But on the other hand, you have to be looking towards the future, and you have to be making sure that you're in alignment with the expectations and the regulations that are going to come that'll govern our industry. So those things are very important. I would say that education is a big key to success, especially when it comes to commercial industry, because like we said, if you're in the industry, you often get it, but if you're outside of the industry, you don't necessarily. So Aaron, what role has your company been playing when it comes to helping the market understand and really embrace this technology?
No, sure. Education and exposure, right, is purely the way to go. I'll give an anecdote and then I'll get into the question. If you go back 15 years ago, perhaps, right, the idea of a Class 8 vehicle going down the road without a physical connection between the driver's hand through the steering column, down through the steer axle to the wheel to actually maneuver a vehicle, in most PD engineers at the time would have laughed you out of the room.
Science fiction.
Exactly. You'd steer that vehicle by wire, right? Today, that's the way it's done, right? Just to be very clear. And that's just a change in the last 15 years. The reason that change was brought about and adopted in a relatively fast pace, much faster than it would have been traditionally before, is through education, right? And education, how these systems actually work, the redundancies, because these are critical safety topics. And so exposure to how you approach some of those questions that are there. So when we think, so and both myself and Tim have been doing this a long time. We were part of that commercial vehicle transition from a steering perspective, right? So we had a front row seat to that activity. So when we think about this product and we think about this activity and what we can do as, let's say, as technology solutions providers for the OEMs, is do that same kind of thing, right? Educate through understanding of the system, the impact that system has, the cost benefit analysis, right? That gets you in the room to begin with. If we think about commercial vehicles, we think about cost, right? That's because again, there has to be an ROI. Fuel is a major topic in commercial vehicle, always has been, always will be. And so when you think about ways to both reduce your transportation cost of fuel, and then the secondary cost of fuel that may be borne to drive the utility portion of the vehicle. These now are the aspects that our OEM customers are very interested in. Now it's the how, right? Again, as I mentioned earlier, using systems that are already at play here in these vehicles. There's nothing new being added, right? The idea of an inverter being added to a vehicle, that's not new. that then generating onboard storage. That's not new because utility vehicles typically have secondary batteries, right? So there's not anything really new that people aren't very aware of on the PD side of the OEMs. It's the application of this configuration that is really the thing that is intriguing, because again, there's no real additive activity. It's more of a architectural activity that drives an outcome that traditionally we weren't thinking about. So one of those aspects is that we will, from a macro market perspective, we will be at CES this year, and with a very large booth, catering to our industrial partners, right? And allowing them to see how that hybridization could work, not only through the drivetrain, if you will, which is what we're proposing, but then how can that power then be used for auxiliary systems in commercial vehicles? And we're really, really excited to have our potential partners and customers and just friends of the market come and really understand how this process could be a benefit to overall heavy duty mobility.
That's excellent. That's excellent. Tim, what would you say is next for your engineering team? Are there enhancements or complementary technologies you've been developing that maybe you're going to be showing at that booth at CES coming up?
Above and beyond the hybrid power transfer case, not yet. And I say yet, because the Emotiv engineering team, we're looking to increase the electrification opportunities, of the hybrid power transfer case to complement additional systems like regenerative braking systems or electric transmissions and or turbochargers as well. So just got the wheels turning, and maybe in the near future, we'll be rolling those things out as well.
So lots of fun going on in your department. Nothing, never a boring day, I assume.
That's right.
Yeah,
That's the way we like it.
So, Aaron, is there something you want to leave us with on the opportunity side, on the risk side, that people really need to be thinking about if they haven't already started?
Sure. No, I would probably take this approach from a macro perspective. When we think about technology in our country and around the world, a lot of our technology advancements, even through the last century, were born by the growth of the mobility markets, right? So I would say automotive markets, and other adjacent mobility markets that played into that. And I think oftentimes we get fixated on passenger car and the impact of passenger car to the market. But what we forget is that commercial vehicles are the picks and axes that actually make that work, right? Without commercial vehicles, there is no automotive market. Without commercial vehicles, I would argue that there aren't many markets that operate very efficiently. And I'll just use the US as a microcosm for the globe. So with that being said, my humble opinion is that for me, the focus on infrastructure for mobility in general, a large part of that thought and strategy around infrastructure has to also equal the impact of commercial vehicle strategy to enable those other adjacent market strategies. And I think this is something that the layperson doesn't think about when they pull up to their local grocery store and they see 15 Class 8 vehicles, right, backed up to docks, unloading goods and produce to this location it's an afterthought, right? They think that they go to the store, goods are on shelves, they buy said goods, they walk out the door, they jump in their car, and then that is that transaction. That transaction largely, again, is born on the back of patrons that understand the market for what it is. But I would think at a macro level, that number is a very small portion of the overall group. So just the opportunity for us to continue, those of us that understand, continue to focus efforts and dollars and investment and technology on the commercial side, that really has the real multiplicative effect on so many markets that the layperson might take for granted that we play in. So that would be the one call to action, right? Is that people really look behind the veil a little bit and understand, hey, commercial is a thriving part of so many industries and employs so many people. It should make sense for us as we think about overall mobility and electrification, which is great, right? And in my humble opinion, I think we will get there at some point as other infrastructure pieces become available. But what can we do today? And so our activity is to approach what can we do as a supplier partner today to help that development arc for overall OEMs in their transition.
You've been listening to the Heavy Duty Parts Report. I'm your host, Jamie Irvine, and we've been speaking with Aaron Rivers and Tim Kelly at Emotiv Mobility. To learn more about Emotiv Mobility, go to emotivmobility.com. Links are in the show notes. Aaron, thank you so much for being on the Heavy Duty Parts Report. I really appreciate it.
No, love being here. Great conversation.
Tim, thank you for adding to the conversation and bringing your technical expertise. Really appreciate it.
You're welcome, Jamie. Thank you.
And thank you for listening and or watching this episode of the Heavy Duty Parts Report. As always, I want to encourage you to be heavy duty. Thank you for watching this video. Click here to subscribe to the Heavy Duty Parts Report YouTube channel and click here to watch another great episode.